Hello, this is a short video presentation on solving systems of equations. Our new unit is going to be on systems of equations. First of all, what is a system of equations? A system of equations is two or more equations with two or more variables solved simultaneously. We will be primarily working with systems in two variables with two equations, although we will do three equations and three variables. What is the solution to a system of equations? A solution is the number, ordered pair, for some reason, I lost my ER, the number, ordered pairs, or numbers, that work in both equations. They must work in both equations. Let's look at a system of equations, and we're going to solve it, and then we're going to check to make sure it actually works in both equations. So let me write the equations. Here's our system of equations. 5x minus y equals negative 2, x plus y equals negative 4. We're going to solve by graphing. We're going to learn several different techniques, 4 altogether, but here we're going to solve by graphing. And we're going to come up with an ordered pair that works in both equations. So let's graph these equations. First equation, solve for y, minus 5x, and we get negative y equals negative 5x minus 2. And I divide by negative 1, divide by negative 1, divide by negative 1. Y equals 5x plus 2. This equation I can just solve using x and y intercepts. So let's draw our graph and see what happens. All right, let's graph this now. And we need a scale. We'll go with 1 and 1. 5x plus 2. So we go up 5. Start here. Up 5. 1, 2, 3, 4, 5. Over 1. Slope is 5 over 1. And we go down 1, 2, 3, 4, 5. And we go over 1. And we draw our line. It's extremely important that your graph is accurate. Our other graph will use the x and y intercepts. X is 0, y is negative 4. 1, 2, 3, 4. Y is 0. Oops, I did that backwards. When y is 0, x is negative 4. When x is 0, y is negative 4. 2, 3, 4. And we join our line, or draw the line. So our line goes like this. We can see right here that we have an intersection. We look for where the graphs cross. This ordered pair is a solution to both equations. This ordered pair, negative 1, negative 3, is part of this graph, and it's part of this graph. All points on this graph work for this equation, right here. All points on this graph work for this equation. The question is, which one works for both equations? So, negative 1, negative 3, we put them into, we check the original equation, we check the original, and we have to do both checks. We have to check in both. So 5x minus y equals negative 2. 5x minus y equals negative 2. X plus y equals negative 4. And we do the check. So 5 times negative 1 minus negative 3 should equal, hopefully, negative 2. And negative 1 plus negative 3 should equal negative 4. Now, notice here we're multiplying. I use parentheses. 5 times negative 5 is negative 5. And this becomes plus a positive. Negative 2 equals negative 2. Check. And negative 1 plus negative 3, negative 4 equals negative 4. Check. We must do the check in both equations. Now, why both? For instance, if I look at the ordered pair here, 1, negative 5, right there, 1, negative 5, 1 plus negative 5 equals negative 4. It works. If I put it into this equation right here, it works. And I think, hey, I got an answer. But I come over here, 5 times 1 minus negative 5 equals negative 2. Minus is plus a positive. 5 plus 5. Clearly 10 is not equal to negative 2. So you have to check in both equations. It's essential, absolutely essential, that we check in both equations. All right, that's all there is to it. Make sure your graphs are extremely neat, and obviously use a straight edge and graph paper. All right, I hope this helps. It should be a relatively easy homework assignment tomorrow, and have a great day.